Picture this: your immune system, the ultimate defender, ready to wage war against any threat to your body. But sometimes it can go haywire, triggering inflammation that wreaks havoc. Now, imagine this: fasting, a practice that seems to hold the key to protecting our bodies from dangerous inflammation. That's exactly what researchers from the University of Cambridge set out to explore. They dug deep into the association between fasting and inflammation, and what they found was groundbreaking. In a study involving 21 volunteers, the researchers observed a fascinating trend. After a period of fasting, there was a surge in a compound called arachidonic acid. Now, arachidonic acid may sound complex, but it's a key player in inflammation, and here's where it gets intriguing. The researchers discovered that arachidonic acid had a remarkable effect on a protein complex known as the NLRP3 inflammasome. You see, inflammasomes are like alarm bells for inflammation, but when NLRP3 inflammasome goes into overdrive, it can spell trouble. And guess what? Fasting seems to dial down its activities. This discovery opens up a world of possibilities. Could fasting be the key to taming inflammation, especially the kind that fuels diseases linked to our high-calorie diets? And here's the kicker: aspirin, a well-known player in inflammation, also interacts with NLRP3. And scientists suspect this inflammasome might have a role to play in diseases like Alzheimer's. Putting the puzzle pieces together, fasting might just hold the secret to not only combating inflammation, but also safeguarding our brains from degeneration. It's a tantalizing possibility that could shape the future of medicine. So, are you ready to explore the science behind fasting and inflammation?
The hidden cause of Alzheimer's may have been identified a century ago. Alzheimer's disease is commonly recognized for its association with the accumulation of protein clumps in the brain. However, another element has emerged in understanding this neurodegenerative condition. Researchers from Stanford University School of Medicine revisited observations made by Alois Alzheimer over a century ago. They focused on large fat deposits he noted, which have been somewhat overlooked compared to protein tangles like amyloid beta and tau. Their investigation zeroed in on a gene responsible for producing a fat-transporting protein known as apolipoprotein E, APO. Variations in this gene, labeled a POE1 to a POE4, are known to affect Alzheimer's risk. Their findings revealed that a POE4, in particular, is associated with higher levels of an enzyme facilitating fat movement. When studying brain tissue samples from individuals with different APO variants, they observed increased fat accumulation, especially in non-neuronal cells called glia. This suggests a potential mechanism for Alzheimer's progression, with toxic materials accumulating in glial cells that support neurons. However, there is much more to uncover, and researchers continue to explore potential treatments to address this fat buildup. Each study contributes to our understanding of Alzheimer's complexity. Some investigations even delve into how the disease may deceive the immune system. Moreover, researchers are expanding their exploration beyond the brain to consider connections with other parts of the body, such as the mouth and gut. While the quest for effective treatments remains ongoing, each discovery brings us closer to unraveling the mysteries of Alzheimer's and developing strategies to combat it.